FRQ number 1. Here are the answers, so you can pause the video and just get your points. I figured I'd start with that. Okay, and then next, here's how. Okay, pretty simple. Okay, number 1, get this typed in your Y1 screen for g of x. And then let's look at a couple things. First thing you have to do is g of f of x. Well, f of x is the graph, g of x is this equation. So to start off finding h of 6, which is what this is defined as, that's g of f of 6. F of 6 input, say it's output, you get 3 for the output. And there's where I'm indicating right there. Then you do g of 3, which means you go to this function, type it in the Y1 screen. Remember this little notation. And remember how to get Y1. I have to open up the computer calculator. Take forever, but I'll show you how to find that one more time. Really good way to do that. You also can do calculate value on while you're in the graph screen. I'm still waiting for the calculator to open. There we go. Okay, so again, second quit. How do you get that y of? It's alpha trace, all right, and then you get that y of, and then you have to make sure you have the right equation in y equals, which I do not right now. Another way of doing this is second calculates value, but you got to make sure your window covers the value that you're up to. So there's 3, so it would show up if I had the right equation in there, of course. I did this earlier to get that answer perfectly there. Okay, and then input, say it again. So where f of x equals 3, that means that's the y coordinate. What are the x's that create that? And that's 2 and 6 again. So that's why we get 2 and 6 for that. Find all the zeros, give them as decimal approximations. That's finding y2 equals 0, y1 equals the equation given as g of x. Find the intersection. Again, with my calculator open, second calc isect. All right, and again, that's not the equations that we see up there. That's for a later question that I have those there for. Right, and then the polynomial dance. You should know that a negative, what was that, x cubed? A negative x cubed graphs like, yeah, there we go. Pen's not working. Pen, there we go. A negative x cubed looks like this. So this part right here, as x decreases without bound, that means you're plugging in x's this way. On the x-axis, here are the outputs. They increase without bound, the outputs. So that's why that is true. Okay, and then is f invertible? Ooh, I accidentally thought about it as g, but I still got lucky. No, it's not invertible because there are repeating y's. So when I invert that, x's will repeat, which is the opposite of the definition of a function. So look at their beautiful description about why that is not your reason for your answer based on the definition of a function. The graph of f has intervals of increasing and decreasing y values. Therefore, every output does not have a unique input value. So both f of 2 and f of 6 both equal 3. So that means if you inverted it, it'd be 3 comma 2 and 3 comma 6, and that's not allowed in a function. Okay, I think that's it for that one, and I'm going to do one video per. Doink, doink.